Hi guys, sorry that I'm not with you today, so here's the next best thing, you just get my voice. Okay, so those of you that don't have the note guide, go ahead and title it Rational Functions, Asymptotes, and Wholes. Now we've seen asymptotes before when we graphed the reciprocal function. It had both the vertical and the horizontal, but that's just a type of rational function, and that's the one that I mentioned we start with because it is the easiest. With other rational functions, there's different characteristics that we have to be able to find, and so that's what we're going to look at today. In case you need the title, again, it's asymptotes and wholes. First thing is that there are breaks in continuity. What that means is it's breaking up the flow of our graph, okay? It's restricting the domain, and in case you don't remember, domain is the x values. Okay, I've never written on this before, so wish me luck. So, all right, restrictions on the domain, restrictions on the x values. And the first one's called a removable discontinuity. Discontinuity is because it breaks up the continuous flow of our graph, okay? So discontinuity, that's all that means. Removable discontinuity, well, here's the definition. Write it down with me, please. If the factor x minus a can be removed, so it can be canceled out. If it can be removed, and you can put in parentheses canceled out, and you'll see examples of what this means as we go through the notes. So if it can be removed, then we'll solve x minus a, and x equals a is a whole in the graph, which makes sense for it to break up the continuity of our function. If there is a whole, well, of course, it doesn't exist there. Okay, so that is a removable discontinuity. The non-removable we've seen before, okay? So if the factor x minus a is in the denominator, so it hasn't been canceled out yet, is in the denominator of the simplified form. So we've already simplified and there's still a factor in the denominator of the simplified form. Okay, then x equals a is a vertical asymptote, and this we saw, and I'm going to go ahead and use VA, vertical asymptote. This we saw with the reciprocal function. Okay, so two types of restrictions on the domain, removable and non-removable. One we've seen, one we haven't, but you'll see both today. Okay, horizontal asymptotes. Well, if it's something other than the reciprocal function, there's certain ways for us to tell if there's going to be a horizontal asymptote, and if there is one, what it's going to look like. Okay, so the first possibility, we'll go with red again. If the degree of the numerator, now remember the degrees are the highest exponents. So we put it in standard form, which means biggest exponent descending to the smallest. The degree is the highest exponent. If you need to, write that down. Okay, so the degree of the numerator, if it is greater than the degree of the denominator, so the top has a higher degree than the bottom, then there is no horizontal asymptote. No horizontal asymptote. Okay, if the degree of the numerator is smaller than, less than the degree of the new denominator, pardon me, then there is a horizontal asymptote. One exists, and it will always be y equals 0. So if the degree of the numerator is smaller than the degree of the denominator, you have a horizontal asymptote at y equals 0. And if I'm not greater than and I'm not less than, what am I? Oh, yes, I am equal to. Okay, so if the degrees are the same, then your horizontal asymptote is at y equals a over b. And this varies depending on the equation. A is the leading coefficient of the numerator, okay, so the number in front. the leading, and you guys will see examples, don't worry, the leading coefficient of the numerator. Guess what b is? I can't hear you, but good job. Yes, I'm sure you figured it out. And b is the leading coefficient of the denominator. The leading coefficient of the denominator. Now, if I went too fast on these explanations, you can always pause it and go back, which is nice about these videos. Okay, so horizontal asymptote has to do with the degree and the comparison between that of the numerator and the denominator. Okay, so let's take a look. Example 1 says determine the restrictions on the domain, so my x values. We are asked, do they represent removable or non-removable? Okay, so that means is it a whole or vertical asymptote? Is there a horizontal, and if so, what is it? Well, in order for me to be able to do this, go back to last week when we were simplifying. The first thing we have to do is factor. So I'm going to rewrite this as 4 over what multiplies to negative 10 but adds to 3, yes, positive 5, and negative 2. Okay, is there anything that we can reduce from the numerator and the denominator? Is there anything that is the same? Hopefully you said no, so right away I can say that there is no hole in this graph, okay? So there are no holes. The vertical asymptotes come from the denominator, okay? If you don't remember that, go back and look. The denominator, yes? So I'm going to have to set my denominator equal to 0, so x plus 5 equal to 0 and x minus 2. This is what we did on the simplifying notes when we were finding the restrictions. Okay, we did that before canceling. So x is going to be negative 5 and x is going to be 2. So we have two vertical asymptotes. We're going to say VA at x equals negative 5 and x equals 2. Now, are those removable or non-removable? I don't remember. Let's look at my notes. Oh, check it out. They're non-removable. Okay, so I'm going to put in parentheses because it asked me to that these are non-removable. All right, the last thing I need to do is look for the horizontal asymptote. Well, the degree of my numerator is 0 because there isn't a variable. The degree of the denominator, if we look, the highest exponent is 2, so it's 0 over 2. If 0 is equal to 2, it would be condition number 3. But we know that it's not. We know that 0 is less than, so we have a horizontal asymptote at y equals 0. And that's all we had to do. Okay, so let's look at number 2. We need to factor both the top and the bottom, so I'm going to say, what multiplies to negative 12? It adds to negative 1. We have x minus 4 and x plus 3. And then in the denominator, it has a GCF of 2x, and we're left with x minus 4. Now, when we were simplifying last week, I had you find the restrictions before canceling. Okay, that still matters, but for finding the characteristics, it's a little bit different. So I noticed that I have an x minus 4 and an x minus 4. Okay, that is what is a, that's the bell. That is what is a removable discontinuity. That's a hole. In order for me to figure out where it is, I solve it just like I would for the vertical asymptotes. So I say x minus 4 equals 0. X equals 4. So I have a hole at x equals 4. Okay, I am going to erase this so I can move down. Okay, sorry. So we're left with x plus 3 all over 2x. Okay, now we can go ahead and solve for the vertical asymptote. We take the denominator, set it equal to 0, so x is 0. Vertical asymptote at x equals 0. This is non-removable. So a couple things to note. Always find the hole first. So if you can cancel, a term from the numerator and the denominator. And remember, when you do that, it just leaves you with 1, yeah? That's your whole, and then you find the vertical asymptote. Now, the degree of our numerator is 1. The degree of the denominator is 1. Since they are equal, okay, going back, since they are equal, we look at the leading coefficients. The leading coefficients are right here. So we have a horizontal asymptote at y equals 1/2. Nice. All right, last example, number 3. Ooh, yeah, good factoring, good factoring. In the numerator, we're going to see what multiplies to -20 and adds to -1. I'm thinking -5 and 4. Do you agree? I hope so. Okay, so 2x squared minus 5x plus 4x minus 10. Remember, there are different ways to go about factoring. This is just the one that I use. Their greatest common factor is x. I'm left with 2x minus 5. Their greatest common factor is 2. I'm left with 2x minus 5. They have this in common. So I pull out the common factor, 2x minus 5, and I group what's left over. Okay, so the numerator reduces what? It factors to 2x minus 5 times x plus 2 all over 2x minus 5. Okay, once we factored, we're able to find if there is a whole. Is there a common factor in the numerator and the denominator? Well, yes, there is. So when we reduce, we are simply left with x plus 2. Now that looks familiar. Any ideas what that might be? Oh, yes, it's a line. Nice. Okay, so the first thing, before we go on to the exciting thing I was going to tell you, is we have a removable discontinuity, which means I had a common factor that canceled from the numerator and the denominator. I'm going to set it equal to 0 to figure out where that whole is going to be. So we say that there is a whole at x equals 5/2 or 2.5. Now, here's the exciting part. Is there a denominator here? Well, yeah, it's the invisible 1, but that means there isn't a vertical asymptote. 1 will never equal 0, so my denominator can never be undefined. As far as a horizontal asymptote, well, there's 2 ways to go about it. First, mathematically, my degree in my numerator is 1, and in the denominator, it's 0. Okay, so we have 1 and 0, which means that the numerator's degree is greater than that of the denominator, so that is no horizontal asymptote. The second way you can go about looking at this is, if I'm a line, do I have asymptotes? No. So right then and there, you can say that it doesn't have any. Sweet, nice job, guys. All right, example number, scrolling. Oops, went too far, so sorry. Okay, so now we have to work backwards. We get to create our own. And this is a little bit unnerving for students sometimes because you will have different answers than the person next to you, and that's okay. It's asking us for a removable discontinuity. Right away, I'm thinking whole. Okay, this is going to be a whole, which means I need a rational function that has a common factor in the numerator and the denominator. Everything else doesn't matter. That's where the freedom comes in. So if I were to work backwards, and I know that x is equal to -4, what factor would generate that? Well, I'm going to add 4 to both sides, and I get x plus 4 is equal to 0. There's my factor. So I'm going to have x plus 4 in the numerator and the denominator to generate the whole. And then I'm going to throw in a 3 because I can, and maybe I'm going to throw in an x minus 1, and I'll throw in an x. All of this extra stuff doesn't matter what it is specifically. What matters is that you have the factor to generate the whole, because that was the one specific characteristic. For 5, we need a non-removable discontinuity. So what is that? Vertical asymptote at x equals 8. And then a horizontal asymptote at y equals 2. Well, since this isn't 0, I know that this is generated from 2 over 1, because I either have 2 options. I can have an asymptote at y equals 0 for horizontal, or I can have a horizontal asymptote at a over b. Okay, so this one's going to be my a over b. For a vertical asymptote at x equals 8. Okay, I'm going to work backwards again, just like we did for the whole. So I get x minus 8 is equal to 0. That's from my denominator. That has to be in the denominator. I can't have that factor in the numerator because then they would cancel out and it would become a whole. And that's not what it asked for. Be careful with those. Okay, horizontal asymptote at a over b. I know that I'm going to have a 2 and a 1. You don't have to write the 1 if you don't want to. And I need to have the same degree. Well, right now I have a degree of 1 in my denominator. How do I fix that? Add a linear factor in the numerator. Anything other than x minus 8. Now my degrees are the same. Whoop, whoop, I am done. All right, last but not least, number 6. 3 things. I need a whole at x equals 3, which means it's going to be generated by the factor x minus 3. I have a vertical asymptote at x equals negative 5. That's going to be generated from x plus 5. Horizontal asymptote at y equals 0. That means that my degree is less than the degree of the denominator. Numerator, denominator. Okay, here we go. So I'm going to say y equals, I have a whole from x minus 3. So that's in the numerator and the denominator. I have a vertical asymptote. X plus 5 gives me that, so that has to be in the denominator. I need the degree of my numerator, up here, to be smaller than that of the denominator. It is already, so I'm done. You can add stuff if you would like, but make sure that you hold true to all the different characteristics that were given to you. Sweet. All right, guys. I hope this was helpful, and I will see you tomorrow. Good luck on your homework.